All right, let's get right into it. Forever, managing late blight has been all about playing the weather. You see favorable conditions on the forecast and you act. But what if that's only giving you half the picture? Today, we're going to talk about a pretty fundamental shift, moving away from those educated guesses based on climate to making really precise decisions based on confirmed inoculum. The actual presence of the pathogen spores in the air. This is the million-dollar question, isn't it? Every single season, it's the same high-stakes decision. The forecast looks just right, the humidity's creeping up, and you feel that clock start ticking. And the cost of getting this wrong? Well, every grower knows that feeling in their gut all too well. Because getting it wrong is really a double-edged sword. You jump the gun and spray too early just based on a weather forecast, you're literally just wasting product, you're racking up costs, and you're putting an unnecessary load on the environment. But you wait too long, you risk an infection getting a foothold that you just can't get back, and that can lead to, devastating crop loss. It's a classic no-win situation. Okay, so this gets to the absolute heart of the matter. The problem isn't that our weather forecasts are bad. Not at all. The problem is that they're incomplete. They're only telling half the story. They are missing the single most critical piece of the puzzle, that biological signal that confirms the threat is actually there. This quote right here, it just hits the nail on the head. Weather describes the opportunity for infection. Think of it like this. The weather tells you the door to your house is unlocked, but it doesn't tell you if the pathogen, Phytophthora infestans, is actually standing on your porch, ready to walk right in. And that distinction, that changes everything. Now, you don't have to take my word for it. Look at the hard data here. This is a meta-analysis from Castaño-Serna and colleagues, and it is just so compelling. You see the models that only use climate? They kind of top out around, 72% accuracy? But look what happens when you plug in that biological signal, the presence of inoculum. Whoa! Accuracy jumps up to as high as 87%. That is a massive leap in predictive power. I love this analogy. It makes it so clear. The weather forecast is like your GPS telling you the highway is wide open, no construction, high speed limit. But aerobiology, that's the science of monitoring these airborne spores, that's your real-time traffic report. That's what tells you if there's actually a ton of traffic on that highway, and more importantly, if it's heading directly for your exit. So the big question is, how do we actually get this missing signal? How do we make these invisible spores visible? Well, it really boils down to a two-step process. First, you've got to capture what's floating around in the air. And second, you use these amazing molecular tools to detect if the bad guy is in that sample. Let's break down the options for each of those steps. For capture, you really have two main flavors, active samplers and passive samplers. The active ones, they're the high-tech option. They give you quantitative data. How much is there? But they're expensive and they need power, which means you can probably only afford a few. The passive samplers are much simpler, way cheaper, and you can build a really dense network with them. They give you a clear, yup, it's here, or nope, not here signal. The choice isn't about which one is better, it's a strategic decision. You're trading off between precision and coverage. Okay, so you've got your sample, now you need to test it. And here, the two workhorses are qPCR and LAMP. Think of qPCR as the gold standard in the lab. It's incredibly sensitive, gives you hard numbers, but it takes a few hours. LAMP, on the other hand, is the sprinter. It's crazy fast. We're talking results in under 30 minutes, and it works with much simpler gear. So again, it's a trade-off. Do you need deep analysis, or do you need a quick answer right now? And then there's this third tool, ddPCR. Think of this one as more of a specialist, like a special ops unit. You wouldn't use it for your routine weekly checks. This is the high-precision instrument you bring in for validation, and this is huge, for surveillance. It is so precise, it can actually detect the specific genetic mutations that are linked to fungicide resistance. That's your early warning system to know if your control methods are starting to fail. So we've got the tools to find the pathogen. Fantastic. But this next part, this is probably the most important piece, and it's where a lot of systems can fall apart. Just because you get a positive test result, that does not mean you automatically go spray. That positive test is just a critical piece of information that feeds into a much, much smarter decision. It's all about moving from a simple trigger to a conditional action. So here it is. This is the core takeaway of this entire explainer. This is the new formula. You only take action when all three of these conditions are met. 1, you have confirmed inoculum is present. 2, you have favorable climate conditions. And 3, your last layer of fungicide protection has expired. It's the intersection of all three that pulls the trigger, not just one. Okay, let's walk through how this actually works in the real world. So it's Monday. You get a positive detection, but you look at the forecast and the weather's not great for the disease. The old model might have had you spraying right then and there, but with the new formula, you wait, you monitor. Then Friday rolls around and the forecast turns. The weekend looks like a perfect storm. Now you have confirmed inoculum and a high-risk weather window. The decision is crystal clear. You spray Friday afternoon, getting that protection on before the infection period starts. That is perfect timing. And you potentially just saved an entire spray for the season. Now, this all sounds great in theory, but I know what you're thinking. Where do I even start? It can feel overwhelming. The key is to think small. Don't try to boil the ocean. You start with a minimum viable pilot program. It's not a giant research project. It's just a small, complete system designed for one thing: learning. And here are 5 totally practical steps to do it. First, just pick 2 to 4 of your high-priority zones. Second, choose a capture method you can actually maintain all season long without driving yourself crazy. Third, find a lab partner and get a service agreement for a super fast turnaround. Fourth, figure out what you want your report to look like from the get-go. And number 5, maybe the most important, treat your first year as a calibration year. The whole goal is to learn. And about that lab agreement, this number is your North Star. It's non-negotiable. From the moment that sample leaves the field to the moment an actionable report hits your inbox, it has to be less than 24 hours. Any longer than that and the information starts to get stale, it loses its value. So the main goal of that first year, it isn't to be perfect. It's to build your very own local data set. You're connecting the dots. You're correlating the detections you get with the weather, with the crop stage, with what you did in the field, and with what happened in the end. This is how you start to build your own localized, data-driven thresholds that are way more powerful than any generic model. So to wrap it all up, this is the fundamental shift in mindset we've been talking about. The old way, climate was the trigger. If the weather's good for blight, you spray. The new way, inoculum confirms the threat first. Favorable weather is no longer a command to spray. It's the final piece of the puzzle that gives you permission to act on a threat you already know is there. And that really leaves us with this one final thought. Your weather app is fantastic at showing you possibilities. It tells you when that highway is open. But the real question you have to ask yourself is, what's your plan for confirming the reality of the threat that's actually on that highway, heading your way?